Okay, let's look at number 2, the number 16, the second part of the calculus study guide here. So this function is still sort of a modified version of 1 over x, except it's like something over x squared. Now, think about what that does. If you take a number and square it, well, of course, it makes a number bigger, but here's the really important thing. Whereas when x was positive, like when you're dividing by a positive, it would go up. When you divide by a negative, like it would go like down to infinity. Well, here's the thing. When you square something, it makes it positive. So even if we got a negative down here, it would instead make it always go up. So here's what the function y equals 1 over x squared looks like. And it still does like the first half of like 1 over x, kind of, except, it climbs a little faster. But the negative half also goes up because you're dividing 1 by a positive number. Now this 7 just makes it climb a little faster. It's kind of just like a slope. And this minus 5 shifts it over to the right by 5. So let's look at a new calculator. First, I'm just going to graph 1 over x versus 1 over x squared. Then I'll show you the other functions that modify it a bit. So this is 1 over x. Okay, notice the positive side goes to positive infinity. The negative side goes down to negative infinity. But 1 over x squared, they both go to positive infinity as you approach 0, that is. Okay, now here's the thing. Now I'm going to reveal what, if it was just 1 over x minus 5 squared, let's reveal that now. So I'm going to highlight that. So again, it's going to shift it over to the right by 5. Okay, and so its bad point is at, dividing by 0 makes your limit go to infinity. Doesn't matter if you approach from the right or from the left, they both go to positive infinity, because again, you're always dividing by a positive. Now I'll show you with the 7 in there. It's not going to look very different from the function marked by the black line. It's going to climb a wee bit faster. So you'll notice it kind of traces pretty accurately the black line. Goes kind of close, it just jumps faster. But again, still has a vertical asymptote at 5, because you're dividing by 0 at 5. Doesn't matter if you approach from the left or if you approach 5 from the right, the limit is going to be positive infinity. So as we approach from the left, the limit is positive infinity. As we approach from the right, the limit is still positive infinity. Now we'll go ahead and do the last point. Think about what this function is going to look like. I want you to just try to sketch. If we did y equals, notice how this is like negative stuff over stuff squared, and your variables at the bottom. Picture what that might look like, okay? If positive, stuff over x squared, they both go to positive infinity. Well, here's the thing, the negative's outside of the x squared. So, can you picture what it's going to do? If you picture this, that's exactly what it's going to do. So what we're going to do is just throw a negative in front of our y equals. If you look at my y equals, I'm going to make some of these other ones disappear. Okay, get this other clutter out the way. So I'm just going to take, I'm going to graph both versions of this. I'm going to put a negative 7 right here. It doesn't matter if you put negative 7 right here, the 7 out, the negative out in front. So remember, our pink one was our original one. The black one is now going to be part 4 of number 16. So you see how they both go down to negative infinity? Again, the pink one was parts 2 and 3. So all it does is flip the function. Now it doesn't matter if you approach from the left or the right. As long as you're approaching 5, your limit this time, because you put the negative, is going to be negative infinity. And that's number 16.